1-5, angle relationships. Pairs of angles. Some pairs of angles are special because of how they are positioned next to each other. For instance, if we have adjacent angles, which are two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. So what this means here is that you can't have an angle inside another angle, but with common vertex, well, we can see from example 1 over here, we have angle 1 and angle 2. They are adjacent because they share this common vertex and they share this common side, okay? Here, example 2, I got angle 1 and angle 2. They share this particular vertex and they share this common side. So these two examples here are considered adjacent angles. Some non-examples, angle 3 and angle ABC, are non-adjacent angles. Well, let's take a look at this third example here. Here's angle 3 and here's angle ABC. This is considered it's not considered an example due to the fact that angle 3 is inside of angle ABC. The next one is this. So here's angle 3 and here's angle ABC. Notice that they don't share a common vertex, which you need to have as one of the criteria to be considered as adjacent angles. And the next one is they have to have a common side, which they do not. See, if we take a look at them, they are not touching each other whatsoever. So this is considered a non-example. All right. A linear pair is a pair of adjacent angles with non-common sides that are opposite rays. So if we take a look at this example here, well, we see that we have angle 1 and angle 2. They got a vertex and they have a common side. So that is considered adjacent. However, in order for it to be considered a linear pair, I'm thinking like a line, right? Well, the angles, you got to have a straight line just like you see here that are opposite rays. So So you have a point and it goes going in that direction, and using that same point, it goes in this direction, and then there's an angle being formed. So this is considered a linear pair. So really, it is a straight line here. This is not considered an example of a linear pair because you can see that, okay, well, here's angle ADB and angle ADC. They share a common point, common side, but we don't see those opposite rays. So this is not an example whatsoever. It's not a linear pair. You have to have a linear pair to be that. Vertical angles, this is something new. You probably haven't heard of this before, but vertical angles are two non-adjacent angles formed by two intersecting lines. So if I have a line here and a line here, they intersect. Well, we can see that angle 1 and angle 2, these are considered vertical angles because they are equal to each other. They are congruent to each other. And we'll get into that a little bit later. Angle 3 and angle 4, these are considered vertical angles, and they are congruent to each other. Really, what I want you to understand from vertical angles is that they form a beautiful X. They form a beautiful X, and we can see some sort of relationship when you have those two intersecting lines, okay? Over here, this is not an example. Angle AEB and angle DEC, they don't really form not a beautiful X. So no relationship there. Okay, because again, if we take a look at this, look how long this angle is, and look at how long this angle is too. We can see that these are congruent. This angle, they are congruent as well, just by looking at how long the angles are. All right. Lines, segments, or rays that form right angles are perpendicular, and to indicate something is perpendicular, we have a specific notation, which is this upside down T, which can be indicated in a figure with a square. So perpendicular, it's that upside down T, and can be indicated in a figure with a square. Perpendicular lines form right angles, right? So if you have a line that looks like this, and you have another line that's perpendicular to that line, well, that's going to form that upside down T, therefore you have this right angle. So let's go ahead and take a look at some examples here. We have number 1. Name 2 obtuse vertical angles. So remember, with the vertical angles, it has to form a beautiful looking X, and it has to be obtuse, okay? So if I look at this example right here, it forms a beautiful looking X, sort of. But yes, it's beautiful. It looks like an X. And this angle here is obtuse, so I can call that angle what? GFH, and angle CFE. So angle CFE. Okay? And then maybe there's another example that we can look at. Perhaps we can take a look at this one. Angle GCB. And also angle DCE. Oh, that's not an E, that's an F. So DCF. Okay? Name a linear pair with vertex B. So here is the B, point B, and when we're talking about a linear pair, I'm talking about like those opposite rays, or you know, that line that we're talking about. So this right here is that line with point B, and then we're dealing with angles, so we got to introduce that part there too. So let's go ahead and say, well, this angle, this angle here and this angle here, they form a linear pair. So angle ABC plus angle CBG. Okay. So once again, with linear pair, you have two angles. They share a common vertex, which they are at point B, and these things form a line. So linear pair. Name an angle adjacent to angle GCF. So GCF. What about, well, if I'm talking about adjacent angles, remember they have to have the same vertex and they have to share the same common side. So here's my vertex right here, and then here's my side. So can I say angle FCD? Or maybe we can consider this. Well, they share a common point. They share a common side here. What about this angle, angle BCG? Okay. And then lastly, number 4, name a segment perpendicular to segment AE. Well, here's AE, and the line that is perpendicular to segment AE is segment GD, which they intersect at a 90 degree. When something is perpendicular, they will always intersect at a 90 degree angle. Okay. All right. Next vocabulary. Complementary angles are two angles with measures that have a sum of 90 degrees. Here's an example. We have angle 1, angle 2. These are stuck together. They're glued together. These angles they form a relationship. We say that angle 1 plus angle 2, they form that 90 degree angle right there. This is another example of complementary angles because, well, if I have this angle here separated from this angle here, well, this was 65 and this being 25. If I add those together, that's going to be 90 degrees. So this is considered complementary. With supplementary angles, however, they are two angles with measures that have the sum of 180 degrees. So, here we have angle 3, here we have angle 4. They form a straight line. We remember that's 180 degrees, right? So this plus this is 180. This is considered supplementary. Or, if we take a look at these separate angles, well, this angle here, 120 plus 60, that's 180. So these are examples of supplementary angles. All right, we're going to go ahead and continue on to the next page of the notes. So some pairs of angles are special because of the relationship between their angle measures. Here we have two relationships here. One, we have vertical angles. So vertical angles are congruent. We talked about that before. We look at this, we see these lines intersect, and you can see that if I compare this angle to this angle, they should be congruent. And if we compare this angle to this angle, they are congruent. Okay, so vertical angles are congruent. Angle ABC is congruent to angle DBE, and angle ABD is congruent to angle CBE, and you have it right there. Now, the angles in a linear pair are supplementary. Now, remember, when we're talking about supplementary, that's just going to be two angles that add up to 180 degrees. And we can see that this is a linear pair because, one, a line is 180 degrees. And if I add these angles up together, again, measure angle 1 plus measure angle 2 is 180 degrees. So these are two things that you should definitely star when you're doing these problems here. So, number 5, this says that find the measures of two supplementary angles if the difference in the measure of the two angles is 18. So if I'm dealing with two angles, so let's say I have this angle here and then this angle here. Well, if the difference in the measure of two angles is 18, I don't even know what this angle is really. It's very, very vague. I'm going to call that x. And then since there's a difference between the two angles, we're going to call this one x minus 18. Okay? Because we're talking about difference, and difference means, subtraction in mathematics. So, we'll call that my first angle, we'll call that my second angle. So the first is x, and the second is x minus 18. These two angles, remember, this plus this is equal to 180 degrees. So x plus x minus 18 is equal to 180. Going to combine the like terms here. 2x minus 18 is equal to 180. So 2x is equal to, well, if I add both sides by 18, that's just going to be 2x equals 198. Okay, so therefore x is equal to 99. Okay, so here my first angle is, so this is 98 degrees. And if I want to figure out the second angle here is, remember, all I'm doing, what I did here was I just replaced the x with 98, and I got to do the same thing for that second angle. So this is going to be 99 minus 18, so that is what, 81 degrees. Okay, so that's my answer. So those are my answers here. So we found the measures of the two supplementary angles, one being 98 and one being 81, and you can check to see if it works. Well, if the difference between these two angles is 18, well, 98 minus 81, wait, what did I do wrong? Oh, sorry, this should not be 98, this should be 99. There you go. So 99 minus 81, that should be 18. Difference, okay. Number 6, find the measures of two complementary angles if the measure of the larger angle is 12 more than twice the measure of the smaller angle. Okay, so we're dealing with two angles here. Before we were talking about two supplementary angles, which I will just add up equal 180. Here with the complementary angles, I'm just going to add up and equal to 90 degrees. So if I draw my angles here, well, let's read this stuff again. Find the measures of the two complementary angles if the measure of the larger angle, let's say that this is the larger angle, is 12 more than twice the measure of the smaller angle. So do I really know what the smaller angle is? No, I don't. So I'm just going to call that x, right? It's unknown, right? So we use x to represent the unknown. So this is my smaller angle. We'll call that x. And then this larger angle is 12 more, so 12 plus, then twice 12 more, 12 more than twice the measure of the smaller angle. So I'm going to call that 12 plus 2 times the x, right? 12 plus 2 times the x. So 12 plus 2 times the measure of the smaller angle, which we represent as x. So here I have these two things, two expressions. So I'll do x plus 12 plus 2x equals, what do I set that equal to? I set that equal to 90 here. Combine 3x plus 12 is equal to 90. Subtract both sides by 12. So you get what? I get 3x is equal to 78. So divide both sides by 3. X is equal to 26. Okay, x is equal to 26 degrees. So that means the smaller angle is 26 degrees. But the larger angle, I gotta go ahead and start replacing that x and then start to add. So 12 plus 2 times 26, that's 64 degrees. Okay, so those are my two answers here. So let me go highlight the answers for you. And there you have it. Okay. Number 7, find the value of each variable. So what do I see here? I see two lines that intersect. They form a beautiful looking x. My goal here is to figure out what x is equal to and what y is equal to. Okay, so since we're dealing with vertical angles, what can you tell me about vertical angles? Well, vertical angles are congruent. That means that this angle here, if I look at this angle here and this angle here, they're congruent. So I can use those arcs to indicate congruency. So then I can do what? 3x plus 50, which is equal to 6x minus 40. And you know, when they are congruent, I just set them equal to each other. So minus the 3x on both sides, add 40 on both sides. So you get what? 90 equals 3x. So 30 is equal to x, right? So 30 is equal to x. I found what x is equal to. I'm good. Now, my goal here is to figure out what y is, right? So first of all, let's take a look. We're gonna see what's going on. We were using vertical angles to set up the equation to find x, but now I gotta figure out what y is equal to. And notice that there's nothing here, so I can't work with that. So I need to look at something else that I can use to figure out how do I set up the equation for y. Well, if we remember, or if we recall, we can see that we have a pair of adjacent angles where the rays are opposite. This is a linear pair. So this means that I can take this plus this and equal that to 180, right? I'm using that idea of the linear pair, so I can use these angles, set them equal to 180, and figure out what y is equal to. Now, notice that I have that 3x here, right? 3x plus 50. If I know that x is equal to 30, I can just replace that. So that's 3 times 30. Let me erase this. So 3 times 30 plus 50, that's what? 140 degrees, right? That's 140 degrees. So then I can go ahead and draw my little arrow to indicate, that's not a little arrow, but you know what I mean. We can draw that arrow, add those angles up. So I have what? 3x plus 50 plus y is equal to 180 degrees. So then, wait, what am I doing? No, don't do that. Sorry. I meant to say 140, not 3x plus 50. 140 plus y is equal to 180 degrees. Subtract. So y is equal to what? 40 degrees. And you got it. I found what x is equal to. I found what y is equal to. Now, something on the test or the quiz, let's say that y is not y, and instead we'll call that angle 1. For the heck of it, I'll call it angle 1. Okay? So, solve for x and find the measure angle 1. So, it's just the same thing. It's just we're not using the variable y, we're just using the variable 1, if that makes any sense. The measure angle 1, I will do 140 plus the measure angle 1 is equal to 180. I subtract both sides by 140. So then that's going to be measure angle 1 equals 40 degrees. Okay, that's the same thing. So that's saying that this angle here is called angle 1. How do I know what the measure of angle 1 is? Well, I just did what I did before. Okay, it's just I replaced the y with this, just in case you see something like this on the quiz or test. Okay. Okay, wow, what is this one right here? Number 8 says find x and y so that line PR and line SQ are perpendicular. And what do we know about perpendicular? If we scroll up here, line segments arrays that form right angles are perpendicular, which we see with an upside down T, and can be indicated in a figure with a square. So when we're talking about right angles, that means it's a 90-degree angle. So if I have this line PR, which intersects at a 90-degree angle, they're perpendicular to each other, that's going to be 90 degrees. So draw that square. Okay. And then just by looking at this, we can see by vertical angles here, right? If this here is 90, then this here has to be 90 degrees as well. Okay? All right. So, how do I set up my equation? Well, we can see that there's y. We can see that there's y right here, and it's literally taking that 90 degrees. It's equal to 190. So, or not 190, 90 degrees. So, I can make that, I can set that equal to 90 degrees. Add 2, or y is equal to what? 92. Divide both sides by 4, so y is equal to 23. Okay, so for y, once again, let me preface this. Here's 90 degrees, right? And this is 90 degrees, and this is 4y minus 2 degrees. 4y minus 2 degrees is 90 degrees, and is mathematics means equal, so I can set them equal to 90 together to figure out what y is equal to. Okay, now here I have this plus this. This will equal 90 degrees, complementary, right? So 2x plus 5x plus 6 equals 90. 7x plus 6 is equal to 90. So 7x is equal to what? 84. So x is equal to 12. Okay. And the idea is to figure out how you're going to set up the equations, and then you should be able to perform the algebra that you know and love, okay? And if I'm going too fast, make sure that you are pausing the video, replaying, and trying to understand what's going on here, okay? The next one is 9. The measures of two complementary angles are 10x minus 5 and 5x plus 20. Find the measures of the angles. Okay, so I got two angles here, two complementary angles. That means I got to set that equal to what? 90 degrees, because complementary means add up, or add two angles, set that equal to 90 degrees. So I have one expression here and the other expression here. Okay, so 10x minus 5 plus 5x plus 20 is equal to 90. So then 15x plus 15 is equal to 90. And 15x, if I subtract both sides by 90, I'm going to get 15x equals 75. So x is equal to 5, okay? Am I done? Well, no, because I got to find the measures of each angle. So we can call that angle 1. So we can call that angle 1, I can call that angle 2. To find the measure of angle 1, I will do measure angle 1 equals 10 times what? Replace the x with 5. Minus 5, that's going to be what? 45 degrees. And then to figure out what measure angle 2 is, that's just going to be 5 times 5 plus 20. And that's also going to be 45 degrees. Okay? That's how you find the measures of the angles. Last problem. Now make the angles in problem 9 a linear pair. So what does that mean? We're dealing with supplementary territory here. So that means that these angles are glued together, they form a line, they are adjacent, blah blah blah. So let's go ahead and do that. We're going to use these same expressions again, except we just got to equal them to 180 degrees. So 10x minus 5 plus 5x plus 20. So 15x. Sorry. Which is equal to, I'm going way too fast, which is equal to 180 degrees, right? Because my goal here is to make the problems as a linear pair. So we've already done the math for this. We've already done the, like terms and stuff. So that's going to be 15x plus 15, which is equal to 180. So 15x, if I subtract both sides by 15, I'm going to get 15x is equal to 165. Okay, now I'm going to divide both sides by 11. And the fact that x is equal to 11, I got to figure out what the measures are. So this is measure angle 1 is 10 times 11 minus 5, which is equal to 105 degrees. Okay, again, if you don't know what I'm doing here, it's because this is what I need to use, replace that x with 11 here to figure out what that measure is, and then measure angle 2 is that. So measure angle 2 is 5 times, replace the x there, plus 20 is equal to what, 75 degrees, and then you have it. Okay, and yeah, that's pretty much it. Basically with the notes here is just you're trying to recall some vocabulary, and then the stuff at the beginning. So you need to know all this stuff, all this stuff. Yeah, very, very important stuff. This is very vocab heavy, and it requires you to use that to set up the equations here. And this is your homework, by the way. So yeah, that's pretty much it, and I'll see you next time.